Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge, average of levels in a binary tree. So in this question, we are required to go ahead for this particular tree, and in this tree at each level, we will be checking that what is the average of that level. So before going ahead with the explanation, let us check what is the question being given to us, and then I'll explain you that how to come up with intuition of this question. So in this question, basically we are given the root of a binary tree and we are required to return the average value of node on each level in the form of an array. Answer within 10 raised to the power minus 5 of the actual answer will be accepted. So basically the answer of the averages are between 10 raised to the minus 5 to 10 raised to power 4, which is being given to us. Means not that only 10 raised to power 4, but it could be any value. But they are simply saying that 10 raised to power minus 4 is basically accepted, minus 5, till that to negative value it is accepted. Now comes the part that how each level is being like and what we are required to consider. See in this, before that, let us go through the constraint. So the nodes of the number of nodes are basically 1 raised to 10 raised to power 4, 1 up to 10 raised to power 4, and the nodes value is basically minus 2 raised to power 31 to 2 raised to power 31 minus 1. So according to all this, we can check that the number of nodes are in such a manner so that if we go ahead with n solution or n log n solution, but not n square solution. Because if it would have been n square solution, then surely there would be DLE, right? So that's why we can go till n log n or even n solution. That's work fine for us. And the node value here, as we are required to find the average, so that's why we would be required to add them up, right? So that's why node value are in the range of 2 raised to power 31 basically and minus 2 raised to power 31. So in that context, we are required to keep a check. Means rather than taking float, we will be taking here as double. Because we all know then that when we will be taking average, so in that context, basically, we will be getting some decimal values and those decimal values could go till 2 raised to power 31. So which is even adding up all of them, it will go to more. So that's why we are required to take double rather than float. So from constraint we got to know this thing. Now let us go to the question, that what exactly we require in this question. So now in this question, let me explain you on the board. So here you can see in this question, we are given with the first node and we are required to keep this particular first node. Basically the average of this particular would be 3 itself, right? And then the average of this particular node 9 plus 20 by 2. That would be its average. And then average of this node would be 15, 7 by 2, right? Now comes the part that how we will be calculating for these averages, right? So now comes the part that tree is being given to us. So how we will be going into this particular tree, means traversing this tree. Either we can perform DFS or we can perform DFS, right? So when we will be performing DFS, so it is by itself level order traversal, right? That means whatever nodes would be there at one level, we will be having knowledge about all those nodes, right? So when we get to this level, then we would be having this node, and that's why we will be able to figure out that this node is being present. So we will be having this as our sum, right? And the next thing is about the count, because in average we require sum and then count, right? So count of that particular level, basically how many number of nodes are being present in that level, that we will be able to get from the size of the queue. Because we all know that when we do a level or a traversal, how we check for all the nodes at a level? Basically we check by the size of queue itself, right? Because in the queue at max, whatever number of nodes are being present at a particular level, that is a maximum which is being stored in the queue. And then we go to other level, then all the nodes which were there at the previous level, they simply get pop out. So that's how we will be able doing this DFS on this question. Basically in each level, we will be keeping the size of the queue with us, which will act as the number of items present at that level. And second thing is sum of the elements which will be there at that particular time with the help of our queue. So this is how our DFS will be helping us. So basically, either we will be performing level order traversal, that is DFS, so that at each level we get sum and size, that's the thing which we will be doing, and push average to the answer. Means as we get a sum and size, right, we'll simply divide the size from size with the sum, basically sum with the size. That's what we will be doing, right? The thing by which we do average, and at that point only we will pushing this to our answer. So that's the thing which we will be doing here. Now comes the next part, that can we do this question by DFS also? Yes, we can do. But the only thing in that context would be that in DFS basically we are required to take our data structure in that manner so that we are able to keep the position, keep the count, and keep the sum at that particular level. So because we all know that DFS is something like going into the depth of a particular tree, right? So when we go into the depth of each tree at each level, then the thing is that we completely get, means at that point we completely lose the instance that what was there at a previous level, right? So that's why we are required to keep the track of that position, and corresponding to that position what is the sum and what is the count of nodes which are being there. So by this only we will be able to figure out that by DFS how we can do this particular question. So let me show you that how we can do. So either do DFS but need to take data structure in that manner that it easily stores and help us out to calculate average at each level. So that is the main context that how we will be performing DFS. So when we do DFS, so we will be going to the left node, right? So at the end it reaches here, then it figure out that now here it is having null, right? So it will start going back, but when it starts going back at that moment of time only, or you can say that if we do pre-order traversal, right? So in pre-order traversal, first we will be calculating our route, right? So here we are having 3, so we will be storing 3 in this particular, and the count corresponding to that 3 is 1, right? And the level corresponding to that 3 is 1, right? So we will be storing all this, and then we go to the 9, right? So level corresponding to this is 2, and the count corresponding to this is 1, and the sum would be 9, right? So when it goes back, then it comes to 3, it was already calculated, so now it will be going to its right call. Okay, my cursor is not visible, right? So it will be going to its right call, right? So then it will check that at level second, right, we got 20. So at that moment of time, it will add that to this one, and it will add count as 1. So that's the thing it will be doing, and then position is remaining same. So now 20 goes down to its left call, so it comes to 15. So at that moment of time, it checks that this is level 3, count is 1, and sum is 15, right? So this is what it got added, and then when it goes back, basically backtracks for any other call which is being left. So right call is being left, so that's why it goes to 7. And at this moment of time, it checks that now the level is 3, and the sum is basically 7, right? And then it will add the count one more to the same. So now like this only we are able to get that what is the sum, what is the count at that level, and what is the level. So by this form only we will be able to figure out that at these positions we are having this sum and this number of count. And then we will be, after that, because this would be stored in some data structure, so then we will be traversing this data structure, and then we will be able to calculate our average, our sum divided by our count, and then we will push that to our answer. So this is the whole context which we will be doing in this question. So this was all intuition behind this particular question. I hope now you can code this particular question, but still either you can pause the video and code, or and then you can check for the solution for the same. But here comes the time complexity. So time complexity for DFS is basically order of n. That's because of the fact, because when we are having a tree like this, a skewed tree, then we will be having all number of nodes till n, right? So basically height becomes equals to n, and at that particular moment of time, so when height becomes n, so because of this fact only, we are having the time complexity as n, because we are traversing the nodes as per the height of the tree. And the space complexity, that also becomes order of n, just because of the fact that when we are having this skewed tree, then at that moment of time only, we are having in our stack at max n nodes. So that's why here also time complexity and space complexity, both of them are order of n, and same goes for the DFS as well. So in DFS also the time complexity would be order of n because of same reason, but the space complexity, that would be also order of n, because there could be some moment of time when we are having the nodes, like you can say that at when we are having nodes like you can say that when we are having a complete binary search binary tree, right? So in that, and even the levels of that is much less, right? So at the last most level, when it is a complete and full binary tree, then in that particular context, you can get nodes which are basically tending towards n only. So that's why at that moment of time, our queue would be having at max n nodes, and that not at means tending towards n nodes, and all the nodes which were above might be become as if they are negligible. So in that context, our space complexity will be order of n. So this was about the time complexity and space complexity. Now comes the part code walkthrough for this particular question. So let me first show you about the BFS approach. So for BFS, what I'm doing here is, so basically in BFS we require a queue, right? So that's why I'm taking a queue here, and this is for our answer because our return type is vector of double, right? So at double, sum equals to 0 because at each level we require a sum, right? And in starting only I'm checking that if root doesn't exist, because there could be a case that root equals to null, because root equals to null is also a tree, right? So at that moment I'll return the answer as it is because there would be 0 as an answer. And then if that is not the criteria, then I will push the root into my queue. And then I'm performing the DFS. And how I'm performing the DFS is, here first I'm checking for the level count, because at each level how many elements are being there, that we will be able to check beforehand itself. And then we will traverse all the nodes which are being there at that particular level. So that's why I'm taking this for loop, and then first I'll completely check what is my first node and pop it out, so that now I can process this and it is not repeated again. So that's why I pop it out, and then I'll add that to my sum, right? And then I'll check for its left and right. If left and right both exist or either of them exist, then I'll directly push that particular into my queue. So that's the thing I'm doing here. And then after coming out of this particular level, now next thing which I'm doing is, here I'm calculating my average. So basically whatsoever sum I got, right, and whatsoever level count was there, that I'll do, and then I'll directly push this particular answer into average to my answer, and then I'll reinitialize my sum with 0. So that's the thing I will be doing for each level, and when this particular queue becomes empty, then it will exit out and return our answer. So this is the thing I will be doing for my BFS approach. So now comes the part for the DFS approach. So in DFS approach, basically, as I told that we are required to keep a data structure in such a manner so that we are able to store the position, the sum and the count. So that's why I'm taking unordered map here. So basically that unordered map, I will be storing level, then count of the elements which are being there, and the sum. So that's how we are taking here, and then I'll be calling my function where I will be calculating my average, and then when I get my this particular unordered map filled, then I will be having this particular loop where I will be traversing this particular, and then I will be easily able to get my these particular average calculated, and then I will be assigned that particular to that what we say, that index in my answer. I stopped. Okay, so that's the thing I will be doing in my DFS. And then after that, so this was all for this particular question, and I'll put the link for the code in the description. And this was all for this. I hope you like the video, and if you like the explanation, then please do share among your friends. So this was all. Thank you.